Trina. Neutrophil is a type of a phagocyte which can be found in the bloodstream. It is the first to respond during bacterial infection that causes inflammation. Let's take a look how it works. And the virus is and the antigen will attract to the cell, and the healthy cell will release MHC that will call the neutrophils, and then neutrophils will release chemokines that will attract other neutrophils, and phagocytosis will...
Monocyte. Monocyte is the largest leukocyte found in our body. It can be differentiated from dendritic or macrophage. It is 8 to 12 hours in response to the site of inflammation. So macrophage is so slow that we need to take time. Monocyte are the largest type of leukocyte. Can migrate within approximately 8 to 12 hours in response to inflammation signals from sites of infection in the tissues, and differentiation into macrophages or dendritic cells to affect the immune response.
Eosinophils combat multicellular parasites and infections. So along with the mast cell, they also control mechanisms associated for asthma and allergies. So let's take a look how an eosinophil will act on the parasite. So this is an intestine. Inside the intestine, there is the presence of a foreign body, specifically the parasite. And the eosinophils will recognize it, and it will release its granules in order to kill the parasite. So if the action is not enough, eosinophils will signal the marrow to release more eosinophils to combat the parasite.
So basophils. Basophils are determined with their S-shaped or bilobe nucleus, and also they are determined by either dark blue or purple specific granules. Allergic symptoms are caused by initial systemic histamine released by activated mast cells and basophils that may lead to shock with laryngeal edema, lower airway obstruction, hypotension. So this is why basophils are considered with mast cells to be the key cells in allergic diseases.
Basophilic specific granules contain much histamine and various mediators of inflammation like platelet activating factor, eosinophil chemotaxic factor, and enzyme phospholipase A. By migrating into connective tissues, basophils appear to supplement the function of mast cell. Both of them have surface receptors for IgE and secrete their granular components in response to certain antigens and allergens.
T lymphocyte came from the lymphoid lineage and become T lymphoblast and further mature as T lymphocytes in the thymus. So the T lymphocytes become activated and become helper, cytotoxic, and memory T cells. So they are the cell-mediated immunity. Immature T lymphoblasts will travel from the bone marrow to the venules of the corticomedullary junction and will go to the thymus for maturation. The immature T lymphocyte will undergo positive selection and will become a single positive T cell. T cells are mobilized when they encounter a cell such as a dendritic cell that has ingested an antigen and is displaying antigen fragments bound its MHC molecules. This is the T cell receptor of the T cell. Cytokines from the macrophage will help the T cell to mature. The MHC antigen complex activates the T cell receptor and the T cell secretes cytokines. Some T cells become helper T cells and secrete some cytokines that attract fresh macrophages, neutrophils, and other lymphocytes and other cytokines to direct the recruits once they arrive to the scene. Some T cells become cytotoxic T cells and track down cells infected with viruses. Some cytokines spur the growth of more T cells and become memory T cells so that when that antigen comes, the T cell will remember it.
Bone marrow is the major organ for the development and maturation of B cells. B cells are generated from human stem cells and developed in bone marrow before they egress into the peripheral blood to reach the peripheral lymphoid organs. In some circumstances, B cells erroneously identify normal cells in the human body as being antigen that requires an immune system mechanism that lies behind the development of autoimmune disease such as multiple sclerosis, scleroderma, and type 1 diabetes mellitus. Let's explore the world of bone marrow.
B cells express B cell receptors on the surface of the cells which allow the cells to attach to an antigen on the surface on an invading microbe. For this reason, B cells are also called antigen-presenting cells as they alert other cells of the immune system to an invading microbe. So B cells differentiate into plasma cells which secretes specific antibody which attach the surface of the infection-causing microbe. These antibodies are Y-shaped and each one is specialized locked into which a matching antigen key fits. So each Y-shaped antibody reacts to different microbes, triggering a large immune system response with the aim of fighting infection.